Hello student, this is the Sangeeta Mansukhani. Video number 173, and in this video I will be explaining chemical properties of the group 17. Okay, yesterday I completely explained group 17 which element, but again I already said in group 17 fluorine, chlorine, bromine, iodine and acetylene. Okay, so fluorine symbol is F, chlorine symbol is Cl, bromine symbol is Br, iodine symbol is I, and acetylene symbol is At. Okay, so today I discuss about chemical properties of group 17. First chemical properties is oxidation state. Okay, so all halogens show -1 oxidation state. Okay, so all halogens represent -1. Okay, so fluorine. In fluorine, only for fluorine represent -1, but other halogen also represent +1, +3, +5, +7. Reason, what is the difference? Fluorine only represent -1, but other halogen represent other oxidation state also. Okay, so reason only for simple, in fluorine no d orbital present. Okay, and in other halogens, chlorine, bromine, iodine and acetylene, in other d orbital are present. So reason, due to this d orbital size increase. Okay, so increase the size. Okay, so we easily remove the electron. Okay, but fluorine no d orbital, so sufficient orbital, so only for complete its octet except one electron. Okay, so its oxidation state -1, but generally all halogens represent -1 oxidation state. So F, more electronegative element, no d orbital. Okay, so can't expand its octet. Then in interhalogens compound like halogen react with another halogen. Okay, like chlorine react with fluorine. Okay, so this is the interhalogen. Okay, then iodine react with the fluorine. So iodine fluoride. So it is also interhalogen. ICl, iodine chloride. But here you see, first element is bigger size and then second one is smaller size. Then we have to say interhalogen compound. Chlorine size is greater than fluorine. Okay, so chlorine react with the fluorine. Iodine size greater than fluorine. So iodine react with the fluorine. So iodine fluoride are formed. Iodine bigger size than chlorine. Okay, so these compounds are known as interhalogen compound. So smaller size of the halogen react with the another smaller size of the halogen, then formation interhalogen. Then interhalogen change its oxidation state. Like these interhalogen represent +4, +6. Okay. Then after, first is oxidation state, got it completely. Then second one is trains in chemical reactivity. Okay, trains in chemical reactivity, that is means first we have to see which is more electronegative. Okay, so initial first element of the halogen, it is a fluorine. Okay, so fluorine, it is a more electronegative element. So then after chlorine, bromine and iodine. So according to the electronegativity, fluorine high electronegativity, then chlorine, then bromine and then iodine. So according to on the basis of the electronegativity, its oxidizing power. Okay, so its oxidizing power on the basis of its electronegativity. So same, fluorine greater oxidizing power, then chlorine, then bromine and then iodine. So this is the decreasing order of the electronegativity and then oxidizing power. Okay, clear? So we have to discuss after oxidizing power. Oxidizing power, we have to say fluorine is a high oxidizing power, but why? See, fluorine react with any halide, another halide. So it is formed fluoride and then halogen as a halogen group. So that is this fluorine easily oxidized other halogen, and here halogen to maybe chlorine, maybe bromine and iodine. That is this fluorine oxidized to all halogen. Okay, so oxidized to all halogen and it is self converted into the halide like fluoride, and then halide converted into bromine and iodine. Then after bromine oxidized only for remaining last iodine. Okay, so that is this fluorine oxidized to the all other halogen. So its oxidizing power is greater comparison than chlorine, bromine and iodine. Okay, that is clear. Then after other example of the represent oxidizing power of the fluorine. Fluorine react with the water, so it is formed halide, hydrogen fluoride and oxygen group. Okay, so this reaction also represent oxidizing power of the fluorine. Okay, because fluorine oxidized to the water into the oxygen. Clear? That is clear. Any have doubt? Okay. Next, trends in the chemical reactivity. We have to see reactivity towards hydrogen. Okay, reactivity towards hydrogen, that is when halogen react with the hydrogen, so it is formed the halide. Okay, like here HF formation hydrogen fluoride, and in acid way also we have to say hydrofluoric acid, HCl hydrochloric acid, HBr hydrochloric acid and HI hydroiodic acid. So HF reactivity maximum comparison than other because its electronegativity, its oxidizing power great. Then third, reactivity towards oxygen. Okay, reactivity towards oxygen. So halogen forms many oxide, but most of the unstable. Okay, because halogen react with the oxygen and to form oxides, but most of the unstable. Like first we have to discuss about fluorine. Fluorine form, there are two types of the oxide, O2F2 and OF2. Oxygen fluoride and oxyfluoride. Okay, here OF2, it is a thermally stable at 298 Kelvin. So fluorine only form two types of the oxide, O2F2 and OF2. Okay, and then we have to see its decreasing order of the stability of the oxide. Iodine easily form oxides, comparison then chlorine, then comparison then bromine. Reason, because between the iodine bond between the iodine, it is a easily break because iodine size comparison than fluorine maximum. Okay, so greater size, so bond length increase and bond length greater, so easily attraction is less, so easily bond break. Okay, and bond easily break, so it is easily form oxide with the another oxygen. Okay, like bromine here form Br2O, Br2, Br3, so they are less stable halogen oxide. Then iodine also form I2O5, I2O5, but these insoluble solid. Okay, and whenever we have to heat, so it is a decompose. They are decomposed on heating. Okay, so these are reactivity towards oxygen. Then next phase in chemical reactivity, reactivity towards metals. Reactivity towards metal, that is any metal like magnesium. Magnesium react with the bromine. Okay, magnesium react with the solid, it is an alkali metal. Okay, so react with the halogen, bromine liquid, so it is a form halide, but it is a solid way. MgBr2, magnesium bromides. So reactivity towards metal, it is a stable way. Okay, and it is formed halide way. Clear? Then so first halogen compound here discussed chlorine. Okay, first compound, halogen compound here we discussed chlorine. Clear? So discovered in 1774 by Std by the action of the HCl on MnO2, manganese dioxide. So discovered by the Std whenever he do HCl on the MnO2. Okay, so by the action of the HCl on MnO2, chlorine are formed. Okay, so it is discovered by the Std in 1774 but established by the Davy. Okay, and Davy according its elementary structure. Okay, so elementary structure represented by the Davy, and he suggested the name chlorine on the accounts of its color. Okay, so Greek word chloros, see chloros, that is greenish yellow. Okay, so Greek word chloros, its meaning is greenish yellow. Preparation. First one is laboratory method. Laboratory method, first manganese dioxide react with the HCl. Okay, manganese dioxide react with the HCl. This is the represented by the sheet. Okay, so manganese dioxide react with the HCl. So formation MnCl2 and then chlorine and then water. So here this is Cl2, chlorine. Okay, so chlorine Cl2. Okay, Cl2. So MnCl2, manganese dichloride, chlorine and water are formed. Okay, so main product is chlorine. Then after other laboratory method, potassium permanganate KMnO4. So its color is purple but react with the HCl. So formation manganese dichloride, KCl and water, but main product is chlorine. Okay, so its color are changed. So we have to easily understood. KMnO4 is purple color, so that convert into the chlorine. So chlorine color is greenish yellow. Okay. Then next method is industrial method. So there are two industrial methods. First one is Dayton's process and second one is electrolytic process. First one is Dayton process. In this process, HCl gas react with the oxygen gas. Properly you see Dayton process it is very easy, but then suddenly this name came. This name will become. So you confused. Okay, but this process it is very easy. See, HCl gas, hydrochloric gas react with the O2 oxygen gas in the presence of the CuCl2 catalyst, copper chloride catalyst. Okay, so here Cl, so convert into the chlorine gas and water are formed. So HCl gas react with the oxygen gas in the presence of the CuCl2, so it is converted into the chlorine gas and water. Okay, then second industrial method is electrolytic process. Okay, in electrolytic process, NaCl react with the water. So due to the electrolysis, at anode and at cathode, different gases are formed. At anode, chlorine gas are formed, and at cathode, hydrogen gas are formed. And main product NaOH are formed. Okay, so in electrolysis, easily we have to separate. Okay, at anode and at cathode. Anode, we have to found chlorine gas. Okay. So these are first one laboratory method and second one is industrial method. Industrial method Dayton process and second one is electrolytic process. Next one is physical properties. Physical properties of the chlorine, greenish yellow color. Okay, greenish yellow gas with pungent and suffocating odor. Okay, its smell is unpleasant. Okay, and suffocating. Then 2-4 times, about 2-4 times heavier than air. Chlorine 2-4 times, about 2-4 times heavier than air. Then chlorine highly soluble in water. When dissolved in the water, so it is easily soluble. So topic is chlorine properties of the chlorine. Okay, chemical properties of the chlorine. So chemical properties of the chlorine, first one is react with the metal and non-metal. Okay, react with the metal and non-metal, like we have to take metal, alkali metal, Na. Okay, so chlorine react with the alkali metal to Na, so it is form compound to NaCl, and it is also react with the non-metal, like we have to take P4. Okay, so chlorine reacts with the P4 and also form the compound PCl3, phosphorus trichloride. So chlorine react with the metal and non-metal also. Okay, then second chemical property is of chlorine. Chlorine react with the hydrogen and its compound. When react with the hydrogen, so it is formed HCl, hydrochloric acid. Okay, and if react with the hydrogen compound, like we have to see C10H16. This is the compound of the hydrogen. And chlorine react with the hydrogen compound, so it is also formed HCl and called eliminate. Okay, carbon, 10 carbon. So C10H16 plus 8Cl2 convert into the 16HCl plus 10C. Then third chemical property is react with the ammonia excess and ammonia react with the chlorine excess. So both each together less and excess amount. In first reaction, chlorine react with the excess amount of the ammonia. In the first reaction, see, chlorine react with the excess amount of the ammonia. Here 8NH3 and here 3Cl2. So convert into the ammonium chloride and nitrogen gas evolved. Okay, so ammonium chloride are formed when ammonia in excess amount. But in second reaction, you see here single molecule of the ammonia and 3 molecule of the chlorine. So second reaction, excess amount of the chlorine. So ammonia react with the excess amount of the chlorine. So it is converted into the NCl3, nitrogen trichloride, and then HCl. Okay, so in the first reaction, ammonia excess amount, so ammonium chloride are formed. In the second reaction, chlorine in excess, so nitrogen trichloride are formed. Then fourth one is react with the cold dilute NaOH, otherwise hot and concentrate. So in both reaction, different types of the product are formed. If chlorine react with the cold and dilute NaOH base, so NaCl form and then NaOCl, side product, byproduct are different. Okay, NaOCl, sodium hypochlorite are formed. If we take NaOH hot and concentrated, so chlorine react with hot and concentrated NaOH, so main product are similar form, NaCl, but byproduct are different. NaClO3, sodium chlorate. Okay, so in the first reaction, sodium hypochlorite are formed and second reaction, sodium chlorate. But mainly product are NaCl, but byproduct are different are formed when react with cold dilute NaOH and then hot and concentrate NaOH. Then next, react with the dry slag gland. Dry slag gland you already know about calcium hydroxide. Okay, so slag gland, calcium hydroxide, CaOH whole twice. This is the slag gland. And chlorine react with the slag gland, CaOH whole twice. So it is converted to calcium oxychloride, CaOCl2. Calcium oxychloride, CaOCl2, and it is a bleaching powder. Okay, and then CaCl2 and then 2H2. So calcium hydroxide react with the chlorine, so it is formed bleaching powder, CaOCl whole twice, and then CaCl2 and H2. Okay, so react with the slag gland, so formation bleaching powder. Then react with the hydrocarbon. Okay, so you already know about two types of the hydrocarbon, saturated and unsaturated. And saturated alkane, okay, and unsaturated double bond and triple bond, alkene and alkyne. So chlorine react both saturated also and then unsaturated also. So chlorine react with the saturated like alkane, and alkane first compound is CH4, methane. So methane react with the chlorine, but this reaction occurs in the presence of the light, sunlight, H the ammonia. Otherwise, ammonia react with excess amount of the chlorine. Then fourth, react with the cold, dilute or concentrate NaOH. Then react with the dry slag lime, react with the hydrocarbon, and react with the water to lose its color. So you practice these reactions, okay? Because in the exams, A and like reactive given, and then find the product, which product are formed. Okay, and in your mind, these reactions perfectly learn. Reason because the question asking from these reaction. Okay, so properly you learn the chlorine react this like alkali metal. So to form this compound. Okay, so you easily understood. Okay, like react with the cold and dilute NaOH. So you completely understood by when cold and dilute NaOH react with the chlorine. So NaCl and NaOCl form. Okay, so first perfectly you see which reactant react and which product are formed. Okay, and then after you practice. And after practice, okay, like one time you write, one time you see, and then after one time you write. Okay, so one time write and then check. Again you check. Okay, and you learn as a rough way. Okay, this reactant react with this reactant and to form this product. Okay, then you easily completely do in your exam. Okay, otherwise you confuse. Okay, clear? And lastly, it oxidizes ferrous to ferric oxide. Like so, that is means chlorine. It is oxidized to others. Okay, bromine, iodine, and then ferrous oxide to the ferric oxide, sulfur dioxide to the sulfur trioxide. So it is oxidized to other also. Okay, then uses chlorine. Chlorine uses first is for bleaching wood pulp. Okay, that is means for manufacture of the paper and rayon, chlorine is required. Okay, then in bleaching cotton and textile also chlorine is required. Then in manufacture of the dyes, drugs and paper industries also, and then some organic compounds like DDT. So for formation of the DDT also required chlorine. Okay, and DDT is insecticides. Okay, then in the preparation of the poisonous gas. Okay, chlorine used in the preparation of the poisonous gas. First is poisonous gas like is phosgene. Phosgene formula is COCl2. COCl2. Okay, then tear gas. You know about tear gas. So tear gas is CCl3NO2. CCl3NO2. Okay, so phosgene gas COCl2. It is a poisonous gas. Tear gas CCl3NO2. So in the manufacture we have to use chlorine. And then third one is mustard gas. Okay, mustard gas, that is means Cl CH2CH2. That side CH2CH2Cl and both of side attach sulfur. So Cl CH2CH2 as CH2CH2Cl. Okay, it is a mustard gas. Okay, then after in sterilizing the drinking water. Okay, so sterilizing drinking water, and then in extraction of the gold and silver. In extraction of the gold and silver, we have to use chlorine. So chlorine most importantly used in our everyday life. Okay, clear? Got it?